Let's take a look at activity 3, computing slope when given 2 points on a line. So as we've seen, any 2 points on a line can be used to determine the slope of the line. In this activity, we'll explore how to find the slope by working directly with the coordinates of 2 points on the line. Let's take a look at the graph to the right. And we can see on this graph, we've got 2 points, 1035 and 3075. Now, if you think about it, if I give you 2 points on a line, those 2 points determine a unique line. If I say, hey, here's 2 points, make a line containing these 2 points, there is only one possible right answer. That's not true with necessarily with other shapes. Like if I said, hey, here's 2 points, make a quadrilateral containing those 2 points, or make a triangle containing those 2 points. Like we see a triangle here, but we could draw another triangle like that. So the fact that 2 points determine one unique line is what is going to allow us to find the slope of that line with only those 2 pieces of information. Now, with these 2 points, in order to find the slope, which we have seen is the change in y over the change in x, that's basically what we're going to do, is use these 2 points to determine those 2 things. So in part A, it asks us, what is the horizontal change? What is this change if you move from the point 1035 up to the point 3075? What is the change in your horizontal distance? Well, you went from the point 10 units to the right of the origin over to 30 units to the right of the origin. So that horizontal change is a positive 20, which signifies moving 20 units to the right. So we're asked to mark this number on the graph. We could put like a 20 over here like that. All right, what is the vertical change? So now if I move from, say, a height of 35 up to a height of 75, now I am changing 75 minus 35 is 40 units in the positive direction. So I have a change of height of 40. Those are the only 2 pieces of information we need to determine the slope of the line. The slope is the change in y over the change in x. And we just divide those and we have a slope of 2. Notice this line is moving if we go from left to right in an upward direction, so that should be a positive slope. That corresponds with that. Okay, let's go to number 2. The variables y and x are linearly related. Find the slope of the line that describes this relationship. So remember, if they are linearly related, that means they have a constant slope. Now, just from these 2 pieces of information over here, if we didn't know that it was a line, it could be lots of different graphs. So we have to be told that it's a line, and then we can find the slope. You know, for example, in this picture up here, if you're told, hey, some graph has these 2 points on it, but you're not told it's a line, I mean, it could be some kind of a parabola shape, or could be some kind of a shape like this. There's lots of graphs that contain those 2 points. But if you're told that there's a linear relationship or the graph is a line, then from those 2 pieces of information, you can find the slope. Now, certainly we could do this problem by drawing a graph, but you can imagine drawing graphs can get very tedious. So a nice way to do it is to just look at your x coordinates here, and to figure out the change in x, you are going to subtract those values. So the change in x. Now, you might think, well, which order should I subtract them in? The answer is, it doesn't matter as long as you're consistent. So let me show you what I mean, because we're going to do the same thing with the change in y. So let's say you do your change in x. Let's say you do 11 minus, oops, that's not an 11. 11 minus 2, and you get 9. Okay, so you did 11 minus 2. Great. Now you go do your change in x. I'm sorry, your change in y. All right, so for your change in y, you got these 2 values. So say you got to be consistent, you're going to go the same direction. So you're going to do 24 minus 9, and that's going to give you 15. So now your slope is the change in y divided by the change in x. And I could reduce that by a factor of 3 down to 5/3, and that would be my answer. Great. Now let's say the person next to you subtracted a little bit differently. Let's say they found their change in x by doing 2 minus 11. What if they do that? 2 minus 11. Is that going to be wrong? The answer is no, as long as they're consistent. So 2 minus 11 is negative 9. So hopefully then, to find their change in y, they did 9 minus 24. Consistent, go in the same order, the same direction. So if they do 9 minus 24, they get negative 15. So now, writing out the slope, change in y over change in x, I get a negative divided by a negative, which is a positive, and then I can again reduce it, and I get 5/3. Okay, so what I want you to do now is problem number 3, which is basically the same exact thing as problem number 2, except you're given the points as ordered pairs instead of a table. So your x values are here, your y values are here. Now, what order do you want to subtract in? It's up to you. You know, it might be easier one way with the negatives. You decide. So do you want to do 20 minus, oopsie, too far, 20 minus 6 and 4 minus negative 3? Great. Or do you want to do 6 minus 20 and negative 3 minus 4? You decide, as long as you're consistent. Pause the video, complete parts A, B, and C. Unpause it when you're done. I'll have all the answers up so you can check and see how you did. All right, let's see how you did. So the first one should come out to be 2. All right, part B comes out to be negative 2/9. Now I want to talk about this one a little bit. If you switched the order and you did these in the reverse order, -1 minus 3 on the top and 5 minus -4 on the bottom, then you would have got a -2 on the top and a +9 on the bottom. Now notice both of these result in a negative answer. The way I did it in black, I have a positive divided by a negative, which is a negative. So I just pull that negative out in front and call it -2/9. 2/9 is the value. -2/9, not 2 over -9. Okay, do the same thing here. If you have -2 over 9, a negative divided by a positive is a negative. So pull that negative out in front and call it -2/9. All right, the last one, we had 0 over 10. Now, if you switch the order, you would have had a -10 here. But it doesn't matter because 0 divided by anything is 0. Let's take a look at number 4. All right, take a look at this graph. Like I said, with a graph, what you want to do is look at it. What is it about? What is it telling me? That's really what question A is asking you. What is the possible context for this graph? So take a minute, pause the video, write down what you think this graph is about. All right. Well, hopefully you said something about riding something, a bus, a train, a subway. It doesn't really tell us, but it looks like we have some kind of a card, like that has money loaded on it that allows us to ride whatever transportation this is. And we had $40 loaded on the card, and then we begin riding and we start decreasing the amount of money available on our card. Part B, what is the horizontal change? Include units. Describe how you found the horizontal change and mark the number on your graph. Well, we've got 2 different points given to us here. We could use these 2 points to find the horizontal change, but in reality, you could use any 2 points. And I think I'll show that. But first, let's use the 2 points that are given to us. So the horizontal change is the number of rides. So here I have 6 rides. And if I go over here to the next point, which is at 12, the horizontal change is 6 rides because I went from 6 to 12. All right, so I did 12 minus 6. So 12 rides minus 6 rides is 6 rides. And it talks about how to describe that, and you should do that. Now, what is the vertical change? So if I do the vertical change here, I went from $30 down to $20. So notice I lost money. So that is a loss of $10. The vertical change, I would want to go $20 minus $10. Oops, backwards. 30. Sorry, just got ahead of myself. 20 minus 30 is negative 10. Now notice I'm being consistent here. So I took 12 rides minus 6 rides to get the 6 rides here. So that means I need to do 20 minus 30 to get the negative 10. I have to subtract in the same order. But it makes sense on the picture. I'm gaining 6 rides but losing $10. And I kind of did that in the wrong spot here, but that's okay. My vertical stuff should be down here. 20 minus 30 is negative 10. Okay. So part D says, what is the slope of this line? So the slope, and it says include units, is the change in y, which is negative $10, divided by the change in x, which is 6 rides. So now I want to take 10 divided by 6. You can punch it into your calculator if you like, or reduce it down. So let's see, 10 divided by 6 is 5/3, which is 1 2/3, which is 1.6 bar. So I'm going to call that $1.67 per ride. We had dollars in the top of the fraction, rides in the bottom. $1.67 per ride. Now, what is the slope telling us? Right, it's literally telling us the cost per ride. All right, this is really important. I really want to take the opportunity to show you that you could use any 2 points on this line. Let's say I want to use this point up here, which is 0 rides and $40. And then I want to use, it helps to find a nice point, right? You want to find one that's crossing in a nice spot, like maybe right here. That looks pretty good. This looks like after 18 rides, I'll only have $10 left. So let's say I use those 2 points. So I'm going to look at my horizontal, oh, that's too fat. Let's do it a little skinnier there. My change in rides, and I'm going to look at my change in money. Oopsie. Sorry. One more. There we go. Okay, so we went from 0 rides over to 18 rides. So that's a 18 rides increase from, let's call this point A to point B. I increased 18 rides. And I went from $40 down to $10, so I lost $30 on my card. So what would my slope be? All right, my slope would be I went down $30 and I got 18 rides. 30 divided by 18, punch that into your calculator. You guessed it, it is 1.66666, which I will round to $1.67 per ride. That is the main characteristic of a linear equation. You could pick any 2 points, and this rate of change is constant. And that rate of change has a special name called the slope. And it tells us something about the scenario. It tells us how it's changing. It's going down. Oh, I lost my negative. Important. It's going down $1.67 per ride, the amount on our card. Did I remember my negative down here? Oh, I didn't. Negative. It's going down $1.67 per ride. And that makes sense with how this line is going, right? In that last previous activity we saw, if we read the line going left to right and it's going down, that's a negative slope because we are losing money on our card. Okay, let's take a look at this last one. A line passes through the points -4, 1 and 4, 6. Determine whether each of these points is also on the line. All right, now we could use graph paper for this, and if you just got graph paper and plotted all these points, you could tell pretty easily whether they're on the same line. But let's talk about how to do this without graph paper as well. And we might look at a graph too. So let's take a look at the situation here. So we're given these 2 points, -4, 1, which is right here, and 4, 6, which is right here. And then we're asked if these 3 points would lie on this line. So we could look at it graphically and see what it looks like. Let's take a look at 0, 3.5. That looks pretty good, doesn't it? Right there. But I'm gonna show you how to verify that. Let's look at 12, 11. We're gonna have to zoom out a little bit. 12, 11. There it is. Oh, that looks pretty good too. Looks pretty close. How about 80, 50? I'm gonna have to get way out here. Let's see. 80 and 50. I don't know. What do you think? Looks like it might be a little below the line just looking at it, but how do we verify that? All right, let's go talk about how we're going to actually verify this. Well, it really has to do with the slope, right? The slope of the line is that slope that's determining the direction of the line going to cause it to pass through the given points here. So first thing we want to do is find the slope between these 2 points. All right, so the slope between these 2 points is 6 minus 1 over 4 minus negative 4, which is 5 over 8. Actually, let me put that over here somewhere. Let's put this so we have room. So the slope between these two guys is 5 over 8. So now, if the point 0, 3.5 is on the line with these 2 points, then I should be able to take either of these 2 points and find the slope between either of these 2 points and 0, 3.5, and it should also be 5/8. I don't have to do them both. Okay, let's take a look at the picture and think about that. Let me zoom back. Let's zoom back into where we were and take a look at this point. Okay, so we know to get from here to here, the slope is 5/8. Now, if the slope between, let's label these. If the slope between these 2 points is also 5/8, well, then they'll be on the same line. Okay, or if the slope between these 2 points is 5/8, then that would force it to go through that, because I already know the slope between 4, 6 and negative 4, 1 is 5/8. So if the slope between 4, 6 and 0, 3.5 is 5/8, then it's going to force it to be on the same line. So I don't have to check them both, just one. All right, so I got to do the green point with one of these red points. So let's do that. I don't know, which one do you want to do? Let's do negative 4.1 and 0, 3.5. So if I do the slope between those 2 points, I'm going to do 3.5 minus 1, so I have to do 0 minus negative 4. So that's going to give me 2.5 over 4. Now, that's kind of a weird number, right? We have a decimal in a fraction. So the way to make that nice is to multiply the top and bottom by 2. Now I picked 2 because if I take 2.5 times 2, I get 5. That turns it to a whole number, and I get 5/8. You could also just divide 2.5 by 4, and your calculator will tell you a decimal. Let's see, 5/8, what is that, 625? And then you could compare it that way. You could always write your slope as a decimal. Remember, every fraction can be written as a decimal. That's fine. And that would also be a way to compare. So then this guy is definitely on the line. And you should get the same thing if you found the slope between 0, 3.5 and 4, 6. All right, go ahead and check points B and C. And when you're ready to see how you did, unpause the video. All right, so as we saw from the graph, what we expected after looking at the graph is verified here by these slopes. Now I went ahead and showed the slopes using both of these points with 12, 11, but remember, you just have to do one. And same thing with determining that the point is not on the line. All right, it would just take 1 point. All right, well, I hope this lesson has helped you understand more about slope.